In this video, we're going to show you how to use the PerfView tool to do a managed memory investigation. In particular, we're going to find something that's commonly called a GC memory leak, where you don't release objects quickly enough, aggressively enough for the GC to collect them, and so you end up using too much memory. We're going to split this demo into two parts. The first part is going to be about collecting the data, and the second part is going to be about analyzing and understanding the data and finding the fix. The application that we're going to use for this particular demo is the PerfView tool itself. This is effectively a real investigation that I did a few months back when I noticed unusual memory consumption in PerfView. The first step in doing a memory investigation is to sort of understand, to decide that you actually have to do one. And the way that typically happens is that you're running your application, and you bring up Task Manager or something like it, and you look at this line, this private memory, and you can see that in this case I'm using 31 megabytes of memory. And as you use the application, you would expect that number to go up or down. So as I opened up this file, I noticed that my memory jumped to 46 megabytes. But you do also kind of have some predictions about what you would expect the memory usage to be. So in particular, if I open a CPU stacks view and open it all the way, so I'm going to open up that and then close it, you would kind of expect that all the memory associated with that view to be collected at this point, right, or to be reclaimed. But if I look at the actual memory consumption of my app, it's still pretty high. It's not back down to that lower value that it was before. And so that doesn't actually necessarily mean there's a memory leak, because GCs might not have happened yet. And moreover is that there might be various kinds of caching involved. So the first time you do something, you remember information for the next time. And those, of course, that things that you remembered used memory. And so we don't know at this point. So it's better if you repeat the operation many times, and each time you notice that the memory just keeps increasing. If that's true, then you do definitely have a memory leak. You have a problem, because it's going to use an unbounded amount of memory. At this point, we really don't know, but perhaps the easiest way to find out is to just do the investigation, and so that's what we're going to do. So we're done with Task Manager, and I want to start the application over so that I get a nice clean baseline. The basic technique behind data collection for a leak is to find two snapshots. Take two snapshots of the GC heap where you believe that the memory consumption, where you know something about the memory consumption. In particular, the typical one is that you're going to get to a particular state, like let's assume right here, right after I've opened this particular ETL file, and then I'm going to take a snapshot. So I'm going to open up another view of PerfView, and I'm going to use it to take a heap snapshot of the first one. And the way I'm going to do that is type PerfView. Okay, I'm going to find the particular process that I'm interested in, and it's this one. And I'm going to do one more thing than just take the heap dump. I'm going to click on this button called Force GC. And what that will do is it will force a GC of that particular process, that selected process. And because I want to make sure that I have a nice clean snapshot. Now, technically, you don't need to do this, because while PerfView does collect both the dead and live objects in the heap, it can also detect what's live and what's dead. So it can not show you the dead objects. But what's true is it can't do as good a job as the GC itself. And the reason is because when you do a GC, you can also run all the finalizers. All the dead objects might have finalizers which do operations and clean up more memory and release other objects as part of their cleanup. And we won't do that if if you just take a heap snapshot. But if you force the GC, you will end up running all those finalizers, and so it will be a little cleaner. Especially with GUI applications, this is important because they tend to have a lot of unmanaged code, lots of finalizers, and so forcing those finalizers to happen before you take the heap is a good idea. So we've gone ahead and done this. You can see we've forced the GC, and that was successful. So now I'm going to dump the GC heap. At this point, it's going out to that process and grabbing all the memory from it and forming this view of all the objects that are on the GC heap. And you can see that we have 16 megabytes of managed objects. There were about 200,000 of them in the heap at that point in time. So now we have our first snapshot, but we don't know whether that's good, bad, or not. We could look at that data file and just look at it and decide, is it sane? Are all the objects that are there make sense to be there? But for leaks, what you typically want to do is then continue your scenario, and in this case our scenario is to open the CPU stacks and then close it again. And see, at this point, we kind of expect that any memory that was associated with opening and closing those GC stack, that stack view, that CPU stack view, is now been reclaimed. We'd like that to be the case. And so we're going to take another heap snapshot. We're going to go back to this other version of perfview and take a heap snapshot again of that perfview process. And again, I'm going to force the GC. And again, that's nice because it cleans everything up. You'll notice actually that, so I'm going to do the force GC. You'll notice that it actually automatically, because I already had a file called perfview.gc dump, it added this .1 in the middle so that I wouldn't clobber it. And that's handy because typically you want to take several snapshots of the same process and then compare them. So perfview makes that easy. So at this point we have our second snapshot, and we can see that in fact there's quite a bit more than in the first snapshot. Let's bring that first snapshot back up. So here's the first snapshot, and you can see that there are 16 megabytes of memory, 200,000 objects. And in the second snapshot, we have 377,000 objects, and it takes 24 megabytes. So we definitely have something to look into, and that's what we're going to talk about in the next video.